So welcome to part 8 of the world prediction model. So as you can see, I just moved all the Jupyter notebooks, the IPYNB that I have into Google Colab. So the reason I moved into Google Colab is Colab has some advantages over Jupyter notebooks. So the first big advantage that I'm going to show you is the use of a GPU, which gives you a lot more flexibility and it's really faster compared to. I'll show you how much faster it can be. Say for example, so right now I'm just going to train this model with a regular CPU. You'll probably notice it's actually taking its own time. So if it shows an ETA of 2 minutes, probably around 2 minutes for each epoch. So assuming there are 10 epochs, that would be like 20 minutes to run the entire training, right? So so that's what it takes time. So let me try and change it back to um, GPU based training. So for that you need to go into runtime and change runtime type, and I'll have to change the runtime to GPU. Now, if I restart the training with the GPU, so you'll probably able to see how quick it is. Now it takes 3 seconds per epoch, so that's almost um, 30 seconds for the entire training. So the training time uh, came down from 20 minutes to 30 seconds. So that is the biggest advantage of Google Colab, and also it directly saves your notebook back into your Google Drive, for safely, storing the notebook. So those are the biggest advantage that I have in Google, that I see in Google Colab. For these reason, especially for the reason that's really fast is what makes me come into Google Colab. So now that we have trained the model, so let's go into the prediction part. So I wanted to show you a couple of things today. So the main thing is about what is model reset. So there is not much information that that's clearly available on over the internet. I had to go through, try it out on my own to find out what does it really mean. So basically to understand it. So I'll show you with some examples. So let's create a model. Just load the old weights, the trained weights into this one. So as you could see here, right? So the first thing that I'm going to do here is, pass in the model, send in the start seed, and I'm gonna ask it to generate the next 100 words or next 100 characters in this case. So let's reduce the gen size to 10 probably. So in this case, and now I'm going to ask it to predict the next 10 characters. So that's what I'm going to do. So what it would do is it will take the word, wonder what will happen, the first sequence of characters, and then it will try to predict the next 10 to if you give 20, then it will probably do 20. So it will try to make sense, add some spaces here and there, create some words, to just make it as as accurate as possible. So it says wonder what will happen the street of something. So it doesn't have to make sense at this point, but it is able to form the words, from the correct words, the correct spellings in some cases, so all those things it's able to make. So that is more important. So it's able to make that step, and at every step. So what I'm gonna do is, so here if you see, I'm just adding the last care. So how this is working is, basically I'm taking the first word as it predicts. So this one, so say even it starts from here. If you see, it starts from this first word, and then it moves on to the second word, right? So say for example, it starts with the word uh, oh, wonder. So this is for the first iteration. So this is the input for the first iteration. So the first iteration, it predicted another word here, saying that the whatever it's given here, it will add one more word here, saying that happened to you. So this will what the input. So this becomes the input for the next iteration, and this becomes the input for the um, next prediction iteration. And okay, so in the second prediction, so it has now, it takes that happen t, and then now it's gonna add happen t, add a space here, right? So a space here. So that would be the next prediction. So in the next iteration, so this will be the next input for the next iteration. So in the third iteration, as you can expect, um, happen t with the space, becomes the next input, and the output becomes happen t t. So with the space here, okay. So and this become goes on, right? So then it becomes happen t th, the, right? So again, the, so the street. So in every iteration, so it goes 4, 5, 6, 7. Since I have requested 10 characters to be predicted, so it goes 10 times. So this is what happens in the entire flow. So to feed the last predicted character to the next input, so that's where I'm gonna use this predicted last character best value that I'm picking. I'm gonna add it back to the input eval. So that's what is happening here. So to the existing expand dimensions, I'm going to add it back to the input eval, right? So there is two ways to do it. So the first way would be, every iteration, I could send the entire input. So now in say, in method one, um, I could send one word at a time, right? Say for example, since LSTM has a memory of its past, of its past, so I could ask it to remember the past, what is happening in past inputs, and just feed the latest prediction as a new input to it. So say for example, so I could just say, so remember the past input sequence. So that's wonder what will happen, and say, so your next input is going to be um, t. So I'm just gonna give this t as input, and it's gonna remember what has happened in the past. So since it's gonna remember the entire time series, over what has happened over a period of time. So now, and in the next iteration, I'll only have to pass what is predicted in the next iteration, that's a space. And in the next iteration, I only have to pass in the next thing, that what is predicted, that is t. So and then in the next, I'll just have to pass in h and then e, right? So I just have to keep going this way. So this is method one. So in met method two, so what I can do is, I'll tell, don't keep remembering what is happening at every time step. I will give you what you want to know. So just forget what happens past. So say for example, I'll just say, um, wonder what happens t. And then in the next iteration, I'll just forget what happened in the past, right? So I'll just say, and then next time I'll pass the entire thing again as an input. So in the next iteration, right? So this becomes input the entire sequence along with the space and then t. And in the next iteration, I'll pass the entire sequence again. Wonder pen. So in every iteration, I'll just pass the entire sequence so that it doesn't have to remember what is happening in the entire time series. So what is this forget what happens in the past? So what is this concept of forget what happens in the past? So the reason we ask it to forget at some point is because there is a in case there is a need for the model, right? So there is one user using it, and then another user coming in, and he wants to use it now. So what happens is, so the next user, when next user comes, there is a need for us to ask the model to forget what is happening at that point, and then so this is a new user. Don't remember what the previous user has been doing. So you just start with the new user, right? So at that point is what you tell her to forget what is happening. So how do we ask it to forget what's happening in the past is what we called model dot no model. We call something called reset states. So this way, it forgets what happened, for the past, for n number of time sequences, and then it will just have to reset and start from the beginning. So there is two ways to train this. Ask, do prediction. One is ask it to remember how to remember the time steps, and then pass in only one item, every iteration, so that it remembers what is happening in the past, and every time you feed in new characters, it assumes that this is a continuation of what has been happening so far. And the method two is a different way, which actually asks it to forget what's happening, and I'll tell you what all the history. I'll start every time from the beginning, so you don't have to remember what is happening, right? So there is two ways to do it, right? So in this case, I'm doing the method one. So if you see here, I am only giving the last character to it. So what I will tell it is, so if you see in this entire area, you will never see me asking it to reset the state. So for the entire loop that is going on, it will simply keep remembering what has been happening so far, and it will make sure that it does that job without any worries. So it will remember what is happening, right? So let's try something. Let's ask it to just forget, within this loop. So the reason I have added this model reset states here is this is really required, because when I restart again, right, with a different set of input seed, then it should basically forget what has happened so far, right? So it should not just continue based on it has been given in the past. So it should, or else it will just basically get confused. So say for example, if I just go ahead and um, just comment it out here, and I change the sequence, basically input seed. Um, So in this case, so it is still trying to continue it has been doing in the past. So it's still remembering the past and trying to continue from there. So this is bad actually. So when the new input seed comes in, it should actually reset the state and then start again. So only then it makes sense for us to um, you know predict again. But in case if we add this inside the for loop, you will really see the difference what is happening. So that is what is more important. So you will really see what is happening here. You'll be surprised to see it can actually make a big difference. So now, since I'm asking it to forget what is the input seed and what is in the past, now the model has forgotten what is actually the history that is happening, right? So the input seed is a lot, and then it says hey D or something, right? Hey D. What happens is, when I give H, then it immediately forgets what has happened in the past. So it forgot that H was the previous prediction it made, right? And then when you ask it to again do another prediction, so it simply doesn't, it lost the touch with what is happening in the past, and it just keeps going haywire. It doesn't understand what is happening in the past. It just keep making mistakes, even though I'm just appending new things into it, but it's still not able to figure out the relationship between the entire history that has been happening, right? So that is a big difference that you would see here. So the important thing is you don't reset states if you are just only passing the last predicted character back to the model as to predict the next character. And if you reset state, just make sure you pass in the entire input again. You ask it to forget what isn't happening so far, and then you make sure that you tell the next time you want to make a prediction, tell the entire story, saying that this is how you start. This is how you started. You started with my lord. Um, you know you have to tell it, we started with my lord, then we came to his, and then we went to add the word and then we went to add the word there, and then we went to add the word street. So you have to tell the whole story. So you need to, when the next input you are passing, you need to pass the entire thing, right? So that is a big difference, that you will see between the purpose of the model reset state here, right? And it is very important that we don't reset it, only reset the model when it's really needed. So it's really needed here, so that's where we are doing it, and it's not needed here, and so we don't do it, right? So that's a big difference here. So hope you guys had fun trying to learn how this model reset works. So it is something not clearly given in a lot of sources, so I had to try and experiment myself and find out what is happening. So hope you had this found this in a video informative. So in the next video, so what we'll basically going to do is try and do some upgrades to this model. How exactly how a Google page would work. So Google, if you notice that Google page doesn't provide suggestions at one word at a time, right? So it gives it keeps varying. Sometimes it gives one word as suggestions. Sometimes it gives two words as suggestions, and sometimes it gives three words as suggestions. You probably might have wondering how does it really happen, right? So that is upgrade that we are going to do in the next episode. So we'll meet back on another video, and we'll upgrade the model. So until then, see you guys. Bye bye.